All right, welcome everybody. Tonight is, or today is the May the 4th in Dallas at least. This is a Robot Builders Night Virtual, a Dallas personal robotics group. We like to meet and gather and just share our stuff. So if you're watching this after the fact, you're welcome to join any Tuesday night or the second Saturday of every month. We have something going on. Just a reminder of some upcoming things this coming Saturday. We have guest presenters from Germany and Switzerland. Miro and Max will talk to us about their ROS-based outdoor rover, or a model based loosely on the European Space Agency Mars rover. And then June 12, we have David Anderson talking about navigating without making a map. July 10 is open, although there's an option that we could swap our meeting and instead descend on Seattle Robotics Society, and they have a Robothon. And then in August, we have a Robo Columbus competition coming up. So let's see, anybody have anything else on the calendar that I've missed? Okay, then with that, let's dive right in. And I think, Murray, you had jumped in to lead us onto this journey tonight. What you got?
Yeah, I've got a little bit of news. I waited too long at the last video conference to make an announcement, which I've done in the mailing list, but we've got a new personal robotics Discord chat channel that everyone is welcome to join. And I'll post another link, because you have to be invited, and the invite links only last a little while, but I'll post another link into the mailing list, which will last like a week, I think, or a few days. But you can always email me if that's expired. But we've broken that server, what they call a server, off into multiple channels, so we'll have help for hardware and software and all sorts of things. The idea is there actually wasn't kind of a personal robotics chat board on Discord. There's competition ones and things like that, but I thought it might be time to actually start our own. So we now have a personal robotics place to talk, and I've gone off recruiting and went to the Adafruit and Pimoroni Discord servers and brought some people back, and there's a few people who have questions about motor controls and things like that we can probably help with. And then beyond that, I've had a couple shipments in the post from overseas, which makes anybody happy usually. And I guess about a year ago, I and a couple people contacted Pimoroni about their optical flow sensor, which is this little guy. And Pixart, who makes that sensor, the actual chip that's on there, makes a alternate chip. This one here, the one that's been around for a couple of years now, was really the chip, I should say, was designed for drones. So its minimum distance is 80 millimeters to infinity. So the camera on here is designed for flying high in the sky. And it turns out that Pixart makes a near 15 to 35 millimeter camera version of the same chip. And so I lobbied Pimoroni, and they've released the chip now. It's going to be out probably for sale in the next week, is what I've been told. And they were nice enough to send me one. So whereas this one is the PMW 3901, which is the drone one, I've actually got it mounted. I can get my power supply close enough on a Pi, and that's actually the new one, which is called a PAA 5100JE-Q, which is actually the chip itself. But I've got a little program running that basically shows direction on the RGB LED, just as a test. And I've begun writing a blog post about using this over different surfaces, because it turns out there's actually quite a lot to learn about this chip. For example, your XY coordinates come back differently, quite a bit differently, depending on the surface. So if you're on a smooth surface like tile versus a rough surface like a fence paling, the fence paling came back like over 1 meter with about 14,000 ticks. The smooth tile in my bathroom came back with about 2,500 ticks. So it's quite a bit different. And I need to contact the vendor, Pixart, and find out, because they talk about it being good for like use inside of houses on vacuuming drones. So I need to figure out how that's meant to happen, because I could, for example, have the robot with its PID controller drive 1 meter forward and then capture how many ticks the thing provides, and then basically dynamically calibrate the sensor. But as soon as it went over carpet, it would change, or lawn. So what I'm doing is, in a blog post, I've tried out about 9 or 10 different surfaces, and it comes back with different results on each surface, and I'll have to figure out how that can be implemented. But it's nice little chip. It works really well, apart from the fact that I need to figure out how it changes over surfaces. But it's going to go on sale, I guess, sometime in the next week or so. And I think that's it. I've been on the Discord channel for the Unexpected Maker products, which are the Tiny Pico and the Feather S2, which are ESP32 microcontrollers, and trying to find effectively any board that can do an I2C slave. So far, nothing. The only I2C slave implementations I've seen are still in C and C++ for Arduino. Nothing in MicroPython yet, as far as I can tell, apart from a few projects that are out there that people have done, but nothing that's coming from a company or from not more than a single individual. Like you'd have to, like Sion Rosenblum, who does Unexpected Maker, has a PR pending to push into the MicroPython library his stuff, which would allow for MicroPython on the Feather S2, which is this board. And that, I think, is closer than the other ones at having an I2C slave implementation. But at this point, I'm probably, because of the push from the Raspberry Pi Foundation for their Pico, I'm likely to probably end up using a Pico, because I think that's going to have a little more weight behind it. So I've got one of their itsy bitsy RP 2040s, and that's the same form factor as the itsy bitsy M4 Express that I've been using on my robot, so I can just push this into the same socket and use it. But again, I'm still just searching for an I2C slave implementation, because the idea is to have the Pi be the master and have one or more microcontrollers as devices. And I think, as we've discussed before, the only one that's out there that's really been around for a while is on STM32s. So David, for example, could probably do an I2C slave a lot easier than I could, but that wouldn't be in MicroPython. That would be in C++. In any case, that's it in terms of development over here. Got another shipment of parts coming. I continue to play. Most of the stuff I've been doing software-wise has been in this, what I'm calling the cross core, which is basically the subsumption architecture using Python asynchronous I/O library to build a message bus, an asynchronous message bus. That's getting closer. It's largely functional, but I've got a bit more work to do on it to be ready to push it to PyPy, which is like the normal hub for Python software. And that's it from me. Next, or if there's any questions.
You've been busy.
No, yeah, I've been busy.
Setting a high bar there.
Well, nothing's yet finished yet. It's all still in development, but yeah, we're getting there.
That's the first step.
Yeah.
All right. Well, thanks. That's cool. Update from New Zealand. So, and what were those surfaces again? You had carpet, you had tile, you had.
I had painted wood.
Painted wood.
Tile, grass, concrete, unfinished birch plywood. My finished matai is a New Zealand hardwood, so it's like a hardwood floor. I had 9, I think, surfaces.
Like 9, and the ticks per inch varied by how much across those?
Quite a lot, anywhere from about 2,500 up to like 13 or 14,000. Yeah.
Maybe what you're going to have to do that is pair that with some kind of sensor, maybe one of those tiny LiDAR sensors or ultrasonic sensor, so that you can somehow correlate the number of ticks per whatever that you got going on. So you just can't do it straight off the flow, but maybe the first couple of times you run through it, the thing can say, "Hey, I thought I moved this far. How far did I really move? Oh, I'm resetting."
Yeah.
You know.
Yeah, that's exactly. I'm planning.
You know.
Yeah. I would use the idea. I'd use getting an echo from somebody.
I think Mr. Anderson put the echo in.
Okay.
That sounds like a song.
Yeah. I was kind of wondering what was going on because I was hearing this weird voice. In any case, Harold, yes, it's exactly what I was planning, is that I've got my PID controller on the robot able to drive exactly 1 meter within like a few millimeters. And I would have the robot drive forward on a surface and then use the calibration off of that to determine what to set for the offset on the optical flow sensor. But as soon as I moved from wood onto carpet, that would no longer be valid. So the only thing you could do theoretically is have a camera looking at what you were driving on, but that's kind of problematic as well.
Maybe there's some way to typically do that, because if you know your area, or you know kind of your area, and you can get a range towards something, and now you can just say, hey, I told myself to go this far, and my rangefinder said I only went this far, and do those same calculations you're going to do by experiment, and do that inside and recalculate that.
Well, what I'm planning, Pixar could put, this is a brand new board from Pimoroni, but the sensor's been around for a while, and Pixar, as far as I know, has pretty good technical support. So what I'm going to do is, once I've kind of got the blog post available, I can point them at it. I'll go ahead and point them at that and actually just ask that question, because in their documentation for the sensor, it says that it should run across multiple surfaces. So they must have solved this somehow.
Yeah, I'm going to say.
Murray, I would take a lesson from Optical mice. I suspect the problem is probably related to your light source. What I would suggest is that you take a low angle light source.
Mm-hmm.
Otherwise, if this is your sensor, and if you're looking straight down with your light source, you probably got a problem. What you really should be doing is something like this.
Well, the only thing, Doug, is that whereas with the PMW 3901 with an 80 millimeter distance minimum to the surface, that one would be affected by light. But this one, I was actually, I wonder if I've got it still. Where did I put it?
They're all affected by light.
Here's the little rig that I had, and it's about 20 millimeters off the ground, and I was just using ambient light inside my house, and the sensor is like 15 millimeters from the ground and largely shielded from ambient light. I don't think this was related to light sources, because, for example, even in my study, without changing the lighting in my study, I was using different surfaces and getting different numbers. So I think
you're missing the point. It's not. It's the angle that the light hits the target.
Yeah.
All right. That's what it does is if it's a really low angle, it's going to emphasize the contrast of any difference or imperfection on the surface, and that's what you're really tracking. So I mean, like I said.
But I use the same exact positioning for all the surfaces, and I track those surfaces like sort of scientifically. I had them.
Well, but that's what I'm trying to say. You're not getting, on some surfaces, you're not getting sufficient contrast to get the right answer. And so what I'm saying is you should be trying. Let me put it this way: if somebody were looking at what you said, I would argue that the variable that you're not.
David, I think you've still got your microphone on. You're creating.
Okay.
Echo chamber.
Okay. Still got it on, David.
Doug, you were saying?
What I'm saying is you're not exploring the variable of angle of the light. That would be my first one. Okay. And because that's, I mean, like I say, that's how they do it on mice.
But you remember
this is a much bigger distance, right? You can't really control the angle of the light, right? With this kind of setup, because
you can't.
There's going to be light coming in from all angles.
This is the worst. This is the worst. All right, and you're going to have some sort of, trying to pick up contrast. So you're going to have, if you're going to overcome ambient, you're going to have to either have a bright light or you're going to have to contain it.
But the LEDs this actually has its own light source. It's using its own light source, which is a constant.
Yeah, but I'm just telling you, that's where you go with it. Your results are saying no. Your results are saying the LEDs on there don't work.
But maybe, but that's the light source that I'm using. And I was testing this in a relatively low, in this study with a relatively low ambient lighting. So the only light source that was being used, as far as I could tell, on the camera of the sensor would be those two little LEDs that are right next to the camera. There wouldn't be
the angle is wrong, is what I'm getting at. I'm not worrying about the actual light per se. I mean, it's probably got to be pretty strong, but the real thing is how it hits the surface. I mean, if nothing else, if you think if you're straight up, where's the reflection going to go?
Well, the only thing I can say is that,
I mean, I'm just throwing out things here that I think that you're not exploring.
Well, the thing is that Pixar designed this sensor for use in robotic vacuum cleaners for 15 to 35 millimeters with a light source that's controlled by the sensor itself, like two little LEDs.
That's fine. That's fine. But that doesn't mean that they put it straight right next to the sensor.
And they have it cover over. If it's in a vacuum cleaner, by definition, it's covered.
You probably need to look at their, what do they call it? When they make they call it their spec design. Or whatever they do when they made the chip. There's probably a spec design with it somewhere.
Murray, those lights and sensor are on the board that Tim Roney built, right?
Yeah, they're not.
So if there's an error of that type, it's Tim Roney's error, not Murray's in a way. Because Murray's using it within spec.
I'm not trying to jump on Murray.
No, I'm saying in terms of solving
what I'm trying to say is, how can we get that sensor to work? What would you do next?
Right there.
And I'm saying the thing you would explore would be, how to increase the contrast. Does that sensor have the ability to actually output its camera view?
No, it's nothing like that. The actual sensor, if you look at the actual spec for the sensor, which I've done, it actually outputs numbers.
Okay, and, well, here's a quick experiment. You could just take a pie camera and shoot it straight at the floor. All right, try to focus it in. I don't know if their lens has got that sufficient minimum focal length, but if you could, and then just very, very light and see what the image does, how it changes, and put it on the different surfaces and see how it changes on the different surfaces. You might find.
Well, go ahead.
Yeah, what I'm saying is you probably will find that a low angle will give you closer results. Remember, even with an optical mouse, if you put it, there probably are some. That's why they use mouse pads, is because there's some surfaces that they won't do a good job with. But they're usually pretty broad. So I'm just saying is what I would suggest is explore the light angle that hits your target and see if you can make that similar for the different surfaces.
Yeah,
that's what I would explore.
I'm thinking like the mouse, though. I'm looking at the mouse here. It's cover, so it's effectively its own little universe. It's in its box. So I'm thinking, any external thing could filter in and get you off just by definition.
I'm taking what you guys are saying, but I have to say that the rig that I built, largely was sheltering much of the ambient light, and the ambient light, as far as I can tell, had very little impact on the actual results. What it seems to be is that the type of material that is being passed by the lens, the level of detail of that material seems to be impacting on the numbers.
Oh yeah, well that would, because it's by definition angle, and so I can see that.
How do you increase the apparent contrast? You do it with a low angled light. I mean, because that's going to make dust on the board. It's going to suddenly pop up. Okay, it's going to make everything part of the sensor. I mean, part of the target. I shouldn't say sensor. The sensor will see the target.
Well, unfortunately, the board that this is on doesn't even have a switch in software to turn off the existing LEDs. It was designed to run with these LEDs. And as far as I can tell, the Pixar...
Just cover them with black tape.
But let me finish. there's actually a
Mhm.
pin on the PixArt sensor that controls the LEDs, and in their tests that I've seen, like their test bed, they use just a pair of LEDs that are near the lens, just like the Pimoroni one. So I don't think it's the Pimoroni fault either. I think this is, like I said, my understanding is that there's probably something that can be done with the, this is a very sophisticated sensor, by the way. It's not like in it's not like in a mouse. That it's actually quite a complicated camera. It's not just a light sensor that reacts to an infrared signal.
Well, any camera is going to be essentially looking at what it sees.
Sure.
So I mean that's, you can do all the post processing in the world, but if you're not picking up a good target, you're not going to get anywhere.
Mm-hmm.
But I'm just saying I'm saying since you've made this much progress,
mm-hmm.
I say the next thing that I would explore, and you can convince yourself if you really want to. Like I said, you can put a Pi camera, shoot it at the ground, and look at the picture coming off the image, and then put that on different boards, and see if you can pick it up, and how could you make their contrast better? You could do that, or you could just simply take a light and go to the side of your test fixture and go down, 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 and see how that impacts it. And so on a given target, just see if you can change the number if you change the light angle.
It doesn't seem to be related so
Murray,
much. Sorry, David,
what surface produces the best result?
Well, in terms of the largest number, surprisingly, it was actually the fence paling, which has no smooth surface, but a lot of almost microscopic surface detail. And so what I'm thinking is that the fence paling having the best shadow contrast, because there's no varnish or anything on it. And I compare that to, let's say, for example, my living room, I've got a Persian rug, which again has a lot of surface detail and a lot of shadow detail. So it seems to be related to the complexity of the image as much as anything.
Did the more complex images have more dots per inch?
Yeah, very much more.
So there you go.
Yeah, exactly. That's my summary, is that it's not related to the angle of the light so much as the complexity of the image, which kind of makes sense if it's a camera.
The angle of the light changes the contrast.
It can.
You will pick up. It will. There's no can. It will, and it will cause you to have more detail. I mean, that's just optics.
So are you getting the ones that do not appear to be working correctly? Are you getting more counts or fewer counts?
Fewer counts, of course. And for example, the way that you could kind of look at this is that if the sensor, I think, is meant to run as fast as 45 inches per second. It can run at a reasonably good clip. But when it does that over the fence paling, no problem. But if I go a little too fast on my bathroom floor tile, it doesn't have that much detail, it effectively drops from like 2,500 to 147. It just, at a certain speed, without a lot of surface detail, it just loses most of the information. So it's clearly related to the complexity of the camera image. And therefore, I think that there has to be, I mean, yes, Doug, I can look at hardware solutions, but I think that there must be, from the PixArt side, a software solution, because they say this is capable of being used in a robot vacuum on multiple surfaces. So I'm kind of thinking they must have a way to figure out that difference in the data. I don't know how,
but did they give you a reference surface and what you should get out of it on that surface?
You mean PixArt or Pimoroni?
Either one.
PixArt.
Well, the Pimoroni has only just released one board to me. They aren't selling it yet, and hasn't.
What about the sensor manufacturer? Then do they give a reference?
PixArt. Well, PixArt doesn't have any online documentation on what they did to test it. No, they've got like quite a lot of sensor data and charts and graphs and stuff like that, but it doesn't really indicate to me enough information. And like I said, I think I'll just contact their tech support and say, this is what I'm seeing. How would you solve this? And see what they say. It can't be that hard to get an email through to them. So, I mean, they make, PixArt's a huge company as far as I understand. They sell a lot of stuff. So I think they're Taiwanese. Is that right? Does anybody know? Can't remember. Anyway, it's an interesting area of discovery because if this thing can be made to work and work reliably, it's, like I said, 15 to 35 millimeters, and that's quite a good sweet spot for a lot of robots. So we could basically have optical odometry or optical odometry assist, you might say, on existing odometry. Or for like Carl's and my projects on mechanic robots, it might be the only way to get decent odometry. I don't know. I tried, Carl, to get them to send you one, but they said another week, and they only had a few left, she said.
Yeah.
And
no worries.
Another week we'll have them on sale.
It's not an issue. I'm committed to exploring this one, the OpenMV Cam H7 Plus. So so I haven't gotten that far yet. I have to catch up with Ray. Ray's played around with it a little bit, but all I've managed to do is power this guy up and show that it's alive and park it and do something else.
Were you going to use that for odometry, or for optical flow?
Well, for all kinds of things. So actually, if we take that as a segue, maybe I'll just jump in and do my bit now. So this guy, I have in mind 2 use cases for the near term. One is to detect orange cones for Robo Columbus, and the other is optical flow. So that's the use cases for this. And that, I can share my screen and show the just flat out amazing progress that I've made in the last week. Hold it, fasten your seatbelts, okay? Take a deep breath. Here we go. Here we go. Now, is that breakthrough or what? I think that's breakthrough. Just look at it. Look at the detail, the engineering. I mean, this is solid stuff, and it's not even a napkin. It's not even a napkin.
I was going to say, is it a napkin?
You got boxes.
Yes, Sheldon, this looks really good.
You got some arrows going on there. You probably got a password up in the right-hand corner there that you should.
Carl, I was told that the higher level of education you have, your handwriting goes downhill. So you're kind of like getting towards the top end because I can't read that.
I'm working on it. You should see my signature. That's the pinnacle of bad handwriting. But so here's the plan. This was and this is actually relatively neat for me. I don't know why it was neat. It was 2 a.m. that night, but I won't have much time if I'm able to build anything for August. So I had to figure out what's the shortest pathway I could get there to at least get out to the first cone and back, something like that. And I figured the fastest thing I could do is to go get an RC truck chassis and then just bolt a sensor pack on top of it and then use the same kind of interfaces on Donkey Car, which is just PWM, throttle, and turning. And then I'll add some kind of power cutoff, an arm thing just for the safety deal. So that's what drove the things I started in the thread over the week of that one Axial Racing, because it looked like a pretty cool, if you're going to get a ready-made platform, it looked like a pretty cool little ready-made platform. And then this is the approach that I came up with. So basically, like the complexity, it starts with the easier stuff and then adds more and more. And I figure if I can do the minimum here, I can at least get out to the cone and back. So it means a safety shutoff. It means like a BN 0855 IMU compass. It means that OpenMV cam for the orange cone. And then I would do like open loop speed and turning commands, right? So I'd do a rough calibrate on the PWM levels to know the approximate speed and then get the rest of the way with camera or something. And then maybe also have some, if it got really crazy on the turning, some kind of adaptive gain so that depending on how fast you're moving forward, you would speed up or slow down the gain on the steering, but I don't know. And then after that, maybe add a servo arm and a wire to touch the cone, maybe like a sensor with one of those resistive flex things so you can know when you're touching it. And then after that, like some movement measurement, maybe it's GPS RTK, maybe it's optical flow, something like that. And maybe after that, avoidance, so sonar, LiDAR, radar, Wallabot, I don't know. and then the whole communicating thing. So I spent a little bit of time on that as well. At the moment, I'm thinking RC controller and then whatever for data telemetry. I don't know if there is any telemetry. So that's
Carl. What kind of range do you desire to have on your phone?
What do I need, or
what would you like to have for range? Like, how far do you want to be away from your?
Well, at least for Robo Columbus is like 100 yards, right? 100 meters. Yeah. And I think if I understand, modern RC controllers can pretty much do that on the ground most of the time. Yeah. But I would still have, that leads to the next thing here, which is what I like to do, like I did this on the on that hover, that Mecanum wheel hover sim thing, is I like to have a mixer, so I can mix in a manual control at the same time the robot's in control, right? So I can like put my hand on the wheel even as the robot has its hand on the wheel. So to do that, I was thinking that yeah, if it's an RC controller, I got the servo PWM and then another one from the robot, and then I just have a little like Arduino Nano or whatever, and just measure them and mix them together, and I just have one signal out to the speed controller. So there's the kind of way that would work. And then comes the fail safe. So I figure that if you got the battery and some master switch, then the Nano thing is always on. It can take the throttle from the radio control or the robot, and then figure out if the radio control throttle is missing, it means it lost signal, so cut off the power. Or if I need longer range, maybe I go LoRa or something eventually. But then there'd be this FET switch, and then that would just shunt the power from the battery over to the speed controller. So it'd be a super hard cutoff, even though I guess most of the speed controllers I look at have signal drop safeties built in. Yeah. But
there's also Pimoroni's breakout garden I'm using on my robot. There's a 10 amp switch. It's an I2C controlled switch.
Yeah.
Do that too.
Yeah, there's a lot like that. So this was but you see, I was thinking this way I could have my mixing and power safety all in one place. But some of the other things I looked at where I found where'd it go? Huh, this guy. So this one, that's kind of nice. It takes RC PWM in, and it'll switch up to 8 amps.
Oh wow!
And it uses the same connectors as I had anyhow standardized for a lot of my power recently, and you can see on my camera it's a pretty reasonable size, right? So. And then the other thing I found was $15 gets you 10 of these, and each one can switch 30 amps or 50, something like that. 15 amps continuous, 30 peak, I don't know. And they're also quite reasonable sized. So anyhow, I got.
Could you drop a link onto the chat for that one?
Yeah, for both of these, sure.
Thank you.
Yep. And that, aside from the RC chassis I was looking at, that's pretty much it. There was a lot of traffic from that on the DPRG D list. If anyone's interested, and you don't have it, I can forward it to you. But basically, a shout out to I guess Murray. No, who was it? Kareem and Marcus, our friend from Vancouver, had some good feedback, and Jesse Brockman as well. So all of those look like interesting speed controller options to consider. Pretty much I was looking at like if it's possible to get a brushless motor with Hall effect sensors that can operate at speed and then take the RPM of the motor straight out of the speed controller. And it looks like that's an option in some cases, but in most of the cases, like they call them censored motors, and they seem to use the Hall effect sensors just to give it a nice graceful startup on the brushless mode. And then once it starts spinning quickly, it just goes kind of open loop, and it uses a different timing mechanism than and anyhow, the ones I've seen, most of them, like for RC World, they don't, even if they're censored speed controllers, they don't output the RPM or they don't output encoder information for you to use. So,
Carl, here's another option.
a servo multiplexer. So,
yeah.
Well, but that's a multiplexer. Is it a summer?
You can have, essentially, you can select, you can have two different sources, and you can select between the sources. So,
yeah,
like
but I don't want to do that. I want to take this. If I'm giving it forward throttle from the robot, I want to be able to either give it more forward throttle from the RC or take away forward throttle by the RC. So I want to mix the commands, which means I have to decode the timing values, add them together, and then and then I want to add the commands together.
Okay, what this would do is allow you to take complete manual control over it.
Yeah,
or
one or the other.
Yeah.
One or the other, yeah, but that's
I'm
a
just
different
saying.
mode in my way of thinking.
Yeah. I plan to use one of these myself.
Cool, thanks though, yeah. Okay, that was my update. Go ahead.
Carl, for the switch, the hard power cutoff switch, does it have to be a radio link, or can it be a physical cable?
Well, it can be a physical cable, but I figure I'm a double E. I got this ham license I've never used. I should really use a radio.
The radio controls we used to use on the cranes had a high frequency for the command, and then a low frequency in the hundreds of kilohertz for range, so that you couldn't get out of the range for control.
Yeah, so you had like a couple of different radios then?
Yeah, so it would be one radio with two transmitters.
Right. Yeah.
So one of them was a constant pulse signal, I think it was, for at the 100 and some kilohertz range.
Yeah.
And that would allow you to get 150, 200 feet away from the crane. The other one was your constant communication for your crane motion.
Yeah.
So
well, so that's what I was thinking, right? Where I think the LoRa can probably get a bigger range than the RC transmitter. I don't know, but I need to look into that. But or maybe one of my ham frequencies.
Transmitter I know is like half a mile.
Well, is that in the air or on the ground?
That is in the air, definitely, yeah. So you're
but I used to do radio controlled sailboats, and maybe it's different over water, but you could get quite a long range, like across the whole lake on a radio controlled sailboat. So
yeah, but something like a chain link fence can mess with you.
That's true. Yeah.
So
and you don't get a lot of chain link fences in the middle of lakes.
No.
So.
I operated, used to fly RC aircraft, and we have a chain link fence that was right behind us. And 300 feet down the field, you're still getting signal from onto your plane as you're taxiing or taking off. I never tried with the chain link fence between me and the plane I'm controlling, though. It's always been behind.
Yeah, that's what I figure. I figure it'll be good enough for Robo Columbus purposes.
Hey, Carl, maybe I missed something, but since you're mixing the signals, wouldn't it be possible to just have your mixer detect if the signal, if you lost the signal, and then cut the throttle?
That would be part of it, right?
Okay.
So it would be an Uber overreaching detector in addition to the one in the ESC. So the one that I would have would kick in before the ESC and just totally remove power from the ESC.
Oh, okay.
But I don't know. There's so many options out there and so little time.
If you're using LoRa, I mean, you could, just basically have your controller, not touch a controller and have it transmit whatever the central values were for the, the joystick, and you just add that in to whatever your current settings are for motors or stuff like that. So That would be.
I agree with you. What range were you getting on your LoRa tests on the ground, Ray?
There was still, let's see, what was it? I don't know if you remember that presentation. I think you have like 148 dBm of
link
or
budget.
dB of budget, and let's see, probably about 1,200 feet away, it was only at like high 90s, close to 100. So I didn't really push it. You know, it was.
So easily a quarter of a mile.
Yeah,
easily.
Without any issue. And it would go around metal buildings and underneath the solar, which is, you know.
I think LoRa was designed for that. The only reason I wouldn't do LoRa out the gate is time, because I'm really limited. So if I can buy an RC transmitter and not have to build something, then that'll save me time.
Yeah.
Yeah, you guys are talking about LoRa. Oh, go ahead, Ray.
Oh, the RC transmitters are expensive. I was surprised.
Oh, I know. Yeah, they can be.
Like
you can get cheap ones too, but
yeah, these little LoRa transceivers that I'm using. It's based on the ESP. I don't know if I can get one in front of my camera here. ESP32. It's got a little OLED display on it. It's got Wi-Fi, Bluetooth. Got a connector on the back for battery, and these are what I'm going to use as my robot, you know, controller. One's going to be in I don't know, kind of a handset or you know, like an RC controller, and the other one's actually going to be on the robot. So, because initially I'm not going to have a lot of trust in the thing, and I want to step in and stop it whenever I think it's gone off the rails and stuff like that. So.
Carl, you mentioned telemetry. Some of those new transmitters, and when I say new, I mean within the last 10 years.
Yeah, I know.
Include telemetry packages that can talk between the transmitter and the receiver, so you can get information back from your helicopter or your airplane.
Oh yeah,
that's might be a quick and dirty way for you to get the telemetry you're after.
Yeah, it could be. I mean, and I even noticed in my quick speed controller research that like some of those speed controllers will output the telemetry straight on a Futaba S bus. So how is that for nice and compact, right? I mean, you got Futaba S bus to begin with, and they just throw the telemetry in there, so straight off the shelf, right? But then the question becomes, great, well, does that package provide the telemetry that you want? And that's probably where it falls down, because, well, I don't know what I want just yet, but I'd be surprised. I'd be surprised if the standard RC menu of options had what I wanted, because, you know, off the bat, the motors don't output RPM. They use them to start off for rock crawlers, but they don't on brushless motors, but they don't output so that you can measure it. Except for the controllers that Kareem was pointing to at Vex, and I think maybe some of the others too. Oh yeah, Jesse mentioned VESIC, the open source motor controllers used in these skateboards and things like that, electric bikes. They actually output on CAN bus or I2C, I guess, or UART. But so many options.
The question, Carl, I had was because I've kind of looked into LoRa as well, as because for some reason my Wi-Fi doesn't even get into my front past my fence. So I was looking at LoRa as a remote. Is the speed at which you can send data very high? I thought it was really slow on those.
But let's ask Ray, because Ray's looked at it, and there is the power spectral. I mean, you trade distance for speed.
Mm-hmm. Yeah.
Yep. Yeah, I think there's there's a legal limit of how much stuff you're supposed to transmit. I'm not transmitting anywhere near that. I mean, you know, the value of two two, the potentiometers and 2 joysticks, and a couple buttons, and that's it. And I'm doing it 20 times a second. It's never or drop data or lost anything. You can also send a packet count, so if the 2 counts are off, if it missed a packet or something. So
yeah, I thought it was dependent upon how many people are around you and how nice you were going to be to them about how much you could throw on the LoRa stuff. I mean, if nothing else is around you going, because it is open, right? And,
yeah.
I'm not trying to say be a jerk, but I've got a guy I know named Heel. He builds dragsters, electric dragsters for his kids, and he's got it lowered up all over the place, and he's got stuff sitting back, telemetry all over the place in that.
Yeah.
So, but anyway, that sum total of my knowledge there, by the way.
Yeah, I don't have a really good answer for you on how much it can do.
Not video though. You're not going to send video.
Limited to like 250 some odd or 254 bytes, I think.
Yeah, basically, I'm kind of in the same category as you, Ray, is that I would be sending, like, I've been using that little gamepad, and it's fine for Bluetooth, and it has a Bluetooth range. So it's only just control information. I wouldn't try to send anything more than that either.
Yeah. And there are on these transceivers at least 100 channels. So I think it's going to be, well, for me anyway. I don't know if any ever encounter somebody on the same channel that I was on out here. So,
is that LoRa channels?
I think it's got at least 100 channels.
Oh wow,
that's my recollection. I'd have to look at my thing. I haven't looked at it in a while. I just used the default, the first one. So.
I just noted that we've just had our first Discord chat question in hardware. So someone with a background in motor controllers can perhaps help this person.
Yeah, I would like to commend Murray there. He's got some chatter going on the Discord channel over there. I mean, when I say some, way more than I've ever had on mine, I think. I mean, I've built some up over time, but you've got a lot real quick.
Well, I actually went up recruiting. So I went over to the Adafruit and Pimoroni and the Raspberry Pi and I went onto a bunch of different servers and put in links, and you can send invites and stuff. So I've been just inviting people, and because obviously the more the merrier, and the more of a quorum you get, the more of a feeling there's people there, you'll get kind of a certain threshold, and people will then start showing up. But there's a lot of younger people too. Like on the Raspberry Pi, it's a lot of kids, and they ask a lot of very normal questions for someone just getting into robotics. So it's kind of a good place for all us old farts to give people who don't have that background a little bit of help. So it's kind of nice that way. And it's very immediate. You're chatting with them in real time, so it's kind of fun.
Yeah. I've been hanging out a little bit on the XOMI channel, and people are asking various different questions. And one of them was like, how do you set the I2C address? Do we do that in software? And I'm like, no, not really. There's a couple of ways, and I've been able to answer, at least, respond to a couple of those things. It feels pretty good to respond and give people some information to hopefully keep them from banging their head in a brick wall for as much as I've done in the past.
Yeah. Harold, I think you had raised your hand earlier. Do you want to
Sure.
march through, spend a couple minutes on the things you've done this week?
Sure, I can do that. Let's see. Let me get up here. Change a couple things. Yep, studio mode off. And I go to full screen. Yes, I'm going to go to that screen. Thank you. And then, hold on. Turn that off. I need to start presenting my entire screen. Yes. And then I'm presenting to everyone, which is great. And I'll figure this out one of these days. So what you're seeing there is my XOMI being in the progress of being built. They got the chassis. I've got the buck converters going in there. I still haven't found the battery because I haven't gone looking for it. I was just going to go down to Hobbytown or whatever and sit there at the RC shop back there where they have all the different batteries and find one that fits. That's at least 7.2 volts and a couple thousand milliamp hours. I've been printing wheels, and I got a little string on the Pet G, but they're coming out really nice. You may notice something a bit funky with that wheel right there. It's all nice and glassy, except for, and that's all plastic, except for there's a little spot about right there that doesn't look right, and that's actual glass. So I haven't had this problem until just I've started printing these things. I basically the part sticks so well to the glass, it takes a chunk of glass out when it comes. Glass. So I've got it been around, but I think I got almost all these parts printed. And give you an example of how they're going to work. This is one of the wheels, and I got in all my servos. This is just a standard servo, but it'll still illustrate what happens. You got these little things here. These fit down into that, which that's a pretty good fit, and these clamp onto it. And then this whole business right here, well, example of how the servo sits, goes in on this, and that will go into the wheel. So that's what you got for each one of these wheels. Just pretty cool.
Nice.
Some of these things are a little tight, but then no, I mean, I think it's going to be all right. Like that right there is about where it's going to sit. So it ought to be right. And I do have a rubber sleeve to go on some of these things too. So that'll fit really nice. It's a bit weird though, because how you need to print this particular part is, if I was just printing this without regards to strength, I'd print it flat side down, and all these little bits that kind of chewed out here, which I might have to reprint all 6 of these things, but we're going to see how far I can get in there. Maybe I can put some inserts in there and have them molded in there and have it be strong enough. But
Harold, the one thing that I found is that, like, I've been starting to prototype the front of a Mars rover using the Servo City stuff, and that particular thing you have in your hand is the one thing, well, apart from the wheels as well, but the one thing that you can't really find on Servo City that I've been looking, I'm going to have to manufacture myself or build, is that kind of, I guess you call it a U shape or whatever, channel arc.
I forget if they call it wheel. It's not a wheel fixer, it's something else. They call it something or another. I forget what they call it. U something or another. They do put the letter in there for the U.
Yeah.
And they have it printed. If you look at there, they have it printed like this. So this is all support underneath here, and the only thing touching is a little bit right here. And so it really makes it hard for these holes and stuff to come out. If I could just print it that way, it would be nice and straight, and all these holes would work well. But what happens then is, because the way this thing's going to be operated, since my layers now go vertical, it's really strong now. The layers won't separate because there's no layers to separate going left and right on this thing. As in, if I'd have printed it like this, the way I'd want to print it, now I've got layers horizontal, and this thing will just snap after you put enough force on it. So I understand why they had it printed that way. It just is harder to print. I'll have to make that happen. Like I said, I got a lot of toys in. Oh, I got these toys in. Look at these things. So this thing, to show you, is going to fit into here. And with my fans on there, I can't fit this daughter board, this hat, on here for all my my PWM servos. And actually, this is a really nice board, but I got another 16-channel servo, it's like a half one of these, and I may try that eventually. But what these are, I believe what David called them was blind via interposer boards, and they came in from from YouTube. I mean, from Adafruit. And literally, I'm like, how did you know I needed these Adafruit? Because literally, these were announced last week as being new. And
well, Harold, in terms of solving the problem on your Pi with the fans, is you can just take two of these stacking headers, two GPIO stacking headers, and put one or two of them on top of each other, and you can.
Yeah, I thought about that too, but then I'm running into a different problem here, because that's about where the Pi is going to live, right there. And as soon as I start stacking them up, I now run out of vertical space to be able to plug crap in.
Well, the other thing you could do then is just take the fans off and put them sideways. You really only need to get motion of, I mean, the air motion around the Pi is all you really need.
Yeah, maybe that's what I need to do. I don't know. I'll work on several different ways here, because I'm trying to figure out how to get all of this in here, and I'm already having problems getting the stuff at the bottom down there because I had to reprint some things and that kind of stuff. So this box could have been made about 20% larger. Just take a mouse and go this way, and you would have a lot more room and a lot more capability here, which, you know, I may end up doing at some point, because that doesn't seem like a bad idea, and it doesn't seem like a hard thing to do, you know, as far as stuff goes, as far as modeling things up. Because I've already had to remodel some other parts, and these little things here, they're supposed to be standoffs so they fit over the battery compartment and hold up the Pi. Well, the problem is that they're so skinny that I think they will snap eventually, and you can't hardly get a nice screw thread going in here, and they certainly won't take an insert. I mean, like I said, I tried to do an insert, didn't work too well for me, and so I'm going to have to redesign these things anyway to do what I need to do, just because if somebody may have printed them well and they had a better luck than I did, but and more power to them, but I think I'm going to redesign these a little bit, maybe give them a bigger footing down here, so have them flare out some. So it's got more of a when it sets flush, it's got a little more support, at least on three sides of it. I can't do it on all four sides because of the way things are mounted in there right now with the holes. But that's kind of where I am and what I'm doing. And I got a box full of printed parts over there, and rocker bogies that look crazy, waiting for servos. And I got a bunch of servos now. It's just time to throw all of this together. I do have the Docker installing the ROS on this thing, so this thing's ready to at least try to do some stuff if I can get all the parts screwed together in it. So that was about me.
Looking good.
Deal. Yeah, and the other thing, I'm going to probably need some experts from you folks, because I know I need to go. There's already a camera plan for it, but I've got to add 2 more servers. So I've got 12 servos coming off of the 16 servo board already. So I'm going to add at least 2 more servos on there for a pan and tilt on the top of the mast for my camera, which will probably be locked straight until I figure out what to do with all that. And then
you're going to be able to support the power that those servers need. I mean, there can be a little bit of a surge. I mean, if multiple of those move at the same time, you're going to have to be able to support that.
Yes, that's one of my fears as well. Because let me go back over here. Yeah, let me go back over here. That's one of my fears as well, because I did install this capacitor because it gave me a place to do it, and it's 1,000 mics, and that's me making a educated guess on what the board manufacturer said, specifically for those power dips you were talking about, Chris, to help smooth that out. And it looks like to me,
well, as long as you have like power that's dedicated to the servos, or is everything feeding off?
No. You're right. This 5-volt regulator here is for the Raspberry Pi and all the other electronics, and this regulator over here is only for the motors. They'll plug right into this terminal block here to provide power directly for the servos on there. So I do have that handled. And I'm just looking at my soldering job on this 2x20, and man, I suck.
Oh, come on now. It's got electrical connection. It's not shorted. Give yourself a break.
No, I just need to do some more. I need to go back and hit these solder pins apart because I don't have full solder around the entire pad there, like you probably should have. At least I did on here. I did on these terminals, but on these right here, like a couple of those right there, you can probably see them. See the little gold peeking out? You shouldn't be able to see any of that. And so, anyway, I'll go back and do that. But quality control. And so, but anyway, I'm liking what I'm seeing. I think it's fairly well designed. I can tell that they have made changes over time. I'm just finding out more changes I'd like to make. Pretty much like for these things, I'm looking at it. I mean, if you do anything, I do not know what kind of logs or ditches or whatever else that somebody's going to throw at us on this challenge part of it. And I don't even know if I can even make it that far. But I do know that as soon as I go over a couple of big rocks and a couple of things, these things are going to snap off. They're just not going to hold very well. And I
don't even think you can run those plastic wheels over a rock without damaging them. I don't think this robot was really meant for outdoors.
Well, that's what they're showing. They're showing on the thing for outdoors. What's going to happen here is I've got another set of prints, another printing session going on. And I'm going to grab some TPU, and they've designed slip covers for these, so that you put a rubber slip over the top of the stuff on this stuff. So yeah, because I'm with you on Murray. I think that's going to be okay for a little bit, but as soon as I hit anything really, really hard or sharp, that might be the end of that wheel. You know,
certainly teeth on it. Yeah,
it depends on how fast you go. If you go real slow, maybe not.
Maybe
I
not.
would say the arm.
Well,
the arm is where you're going to have the main problem.
Last stream, I forget who it was, but said that these rocker bogies, they can go over lots of things, but they'll never go fast. And I'm like, okay, I'm just I'll be a little slow on that. That's fine. The other thing that I'm going to need that I'm going to probably have questions on is I know people like the B&O 55. Didn't they have a big brother or a newer
85.
brother? 85. I'm going to need one of those. I'm going to need some kind of GPS for me to track kind of where I'm going, along with my camera. And then because my plan was to use my Microsoft MVP power, so to speak, and train up some AI on the edge, and to look for those cones, and do a custom vision implementation, and then download that model to the edge. So I believe the rule says something about it has to be encapsulated itself. It can't be controlled by something else. It has to do all the controlling. And I assume that to me that it needs to do its own image recognition and all that kind of stuff as well. That's how I read those rules. And but if I got AI at the edge, it should suffice for all of that. For doing that, and that should be fun because I can actually use some of the stuff I've been playing on the last 3 or 4 years and trying to teach people to use and that kind of stuff. It'll be a good time. That'll be a good time.
Very cool.
Yeah.
Very cool. Thank you. All right.
Yep. I believe I am done.
Very cool. Yeah, you got some thumbs up in the view. That's awesome. Yeah. All right, so let's see who's next. I think Ted, you had your hand, and Chris. Oh, Chris is he's more Eastery. So,
all right,
I'm stopped presenting now.
So
let's follow the sun then. We'll follow the sun. Although with the north and south, I don't know what that means, but we'll go east to west anyhow.
Thank you. Let me see if this works. If I share my other screen, which is displaying my camera, so I don't know if this is gonna come through or if you're just gonna see a blank screen. Let me know in a second. What do you see?
Ooh.
Oh, that's spectacular.
Oh, wow. That's scary looking, man. I think it's gonna kill me.
Yeah.
Okay. So
is that from the Matrix?
Raspberry, 2 raspberries.
So you can see this, right? I wasn't sure because how this works. So I finally managed to settle on a sensor arrangement here on my Romy platform. So I decided for the longer range IR sensor in the front. You can actually see the IR very well here, right?
Yeah.
So this is the longer range, up to 150 centimeters in the center, flanked by the two sonars, front facing straight ahead, and then at a 45 or so angle side facing, I have the shorter range IR. So again, a couple different permutations of this, I guess, that were possible, but this is what I decided to put. And, with all the old wiring out of the way, it kind of managed to wire this up. And you don't actually see too many wires. I made a couple custom wires that were just as long as necessary, so I don't have like inches and inches of wires accumulating there in a tight space. So that's all done and wired up, and I'm getting data back. And one thing that has come up previously, in the context of these cheap HC 04 sensors, they're very inconsistent. And I have a bag full, and many years ago I labeled them grade 1 and grade 2, and I don't remember what criteria I had used. I think I was mainly looking at how fast I could ping them, and I only had one grade 1 sensor and everything else is grade 2. And everything is hunky-dory in a shorter range. So these two numbers is what we're looking at, right? So the 55 and the 45, well, okay, you can already see some inconsistencies there, but I'm not so worried about that. Point is, short range, they both do what they're supposed to do, subject to a little bit of an offset that I'm not sure exactly what that's about. Bigger issue is, so now I'm going out much further, around 2 meters away, sort of the other wall here. And now you can right away see the difference in quality between the two sensors. And I really should have tried all my sensors before putting one in there, because you can see this guy over here, which is now displaying some 30 something millimeters, right? This guy over here is rock solid. It's like 2100 millimeters, right? 2 meters or so, bouncing around a little bit, but it's pretty solid. The other one is just bouncing around like crazy, right? I mean, it's just all over the place. If I stop this, it becomes maybe more obvious. I don't know how this comes across with all these new moving numbers, but it's pretty obvious here that this guy is just bouncing all over the place. So it's not a bad sensor, but it's just really, really not, there's something going on there, and
Hey, Chris.
we have to take that one out and have to try all of them. And I could tell right away that some of the sensors I have, I don't want to say I can hear the ping. I mean, obviously I don't hear the 40 kilohertz or whatnot, but there's a little bit of an audible sound that they make, right? And 1 or 2 or 3 of them that I have, I can really, really hear well. I mean, you put the ear up to it, I mean, I can hear it right away, the clicking sound. And the good one on here, the one that's giving the consistent readings, I mean, it's making a very strong clicking sound every time it pings. And the other one makes a very faint sound. So I have to try some of the other sensors I have. Again, I previously labeled them all grade 2 and grade 3, but I may have been looking at the wrong metric. I may have been looking at how fast they can ping them and not, how well they do at the distance.
Well, Chris, is there some chance that they're interacting with each other?
Go ahead.
Is there some chance they're interacting with each other?
Well, okay. Good thing you asked, because I did sort of think about that. So what I thought, I thought, okay, maybe that's quote unquote strong sensor is producing so much signal that the other one picks it up. But I should say what I'm doing here is I'm pinging them alternately. Okay, so every 25 milliseconds I ping a sensor. All right, so there's a fair amount of time that elapses. So each sensor individually doesn't get pinged more than once every 50 milliseconds, because there's only so fast you can go. And again, it's you know, some sensors you can go faster than others, but I'm only doing a ping every 25 milliseconds. So whatever sound has come out of one should have fully dissipated, right? But here's what I thought I'd do is, okay, so if I completely block or absorb the sound coming out of the strong one, you can kind of see the 36,000. So that kind of means I don't get any signal anymore. It's times out. I mean, the other guy is still doing the same thing, right? Still all over the place. Now, here's what's interesting. If I put this piece of foam, right, in front of the quote unquote bad sensor, it's still all over the place. I mean, it's I don't know why it's behaving that way, right? Well, I'm absorbing all the sound, so it's not getting a signal. So I guess the point is, I guess really my takeaway is this quote unquote bad sensor, the one that's now at 60 something millimeters. You know, once you're beyond a certain distance, and I don't know where the cutoff is, right? I mean, it's doing okay for sure out into the, I don't know, let's say 1 meter range. Again, I haven't quite tested it. But once you get out there a bit beyond 1 meter, it's just not picking up its signal anymore. It's just not, again, I can hear it, like I said, it's probably just not putting out strong enough of a ping, and it doesn't pick it up. And shame on me for not testing my bag of sensors to pick, you know, to pick the two best ones. But you know, I probably not going to worry about it for now, because, you know, I should really spend more time on actually making it do something useful. That's what I need to do next. Yeah, I need to make sure everything else still working. My BNO 85, which is still attached to my other coprocessor, you know, is still there. It's not spitting anything out right now. So I broke something along the way that I need to look at. And then,
Chris,
before I make it fully autonomous, I'll probably make use of my PS3 controllers, which, you know, I haven't used in a while. I've been using this Pololu app. You've seen me demo that with the touchscreen on the phone, but, you know, this is a little more easier to use, and it's actually already connected to the Pi. So I'll make use of that for you know, interactive and semi-autonomous mode. I mean, the thing I want to try next is you know, kind of what we talked about for the you know, telepresence robot, where I want to, you know, sort of control it with a controller, but have the obstacle avoidance kick in as needed, right? So I can't, you know, smash it into a wall. I want to see what that sort of looks like and feels like, and if it's any fun to control it that way. So I can just say, okay, you know, step on it, right? And it'll go as fast as I let it go. And, you know, at some point it's going to decide to steer on its own or stop, or, again, I haven't thought through the logic yet, but I thought that would be interesting to put some logic like that in place and play with it a little bit and see how it goes. So that's kind of the next step for me right now. I don't know if anybody else has the Bluetooth PS3 controllers. I mean, I find that sometimes I decide to not bond to the Bluetooth on the Pi. Again, sometimes it works, sometimes it doesn't. You know, so it's a little, you know, little inconsistent results there. But other than that, it's a great little gadget. The only downside will be that I have to be within Bluetooth range. So, but that's fine.
Yeah, Chris,
could we see the bottom of the robot?
Sure. All right. So for that, let me just do it low tech. The bottom looks like this right now.
So you did end up going with the USB.
Well, I have both right now. I did wire up the USB with my custom little USB-C connector and ribbon cable, so it's all very low profile and flat and flexible and so on. I am using the I2C right now, so well, the data is not on this, wasn't on the screen earlier, but I have both options on the table. Again, it's not yet utilized in any of the logic. Like I said, I really need to put some logic together, make use of it. But I do have both options on the table: getting to it over I²C, and getting to the data over serial. You know, as long as I don't run into major issues with I²C, I'll keep using it and see what I learn. And you know, I want to see what issues I run into. So far, it's been fine. I've even, you know, and I do get I²C issues occasionally, and I don't know if you saw it on what I was just presenting earlier in the screen there. When I talk to my Romy controller, I keep track of errors that I get, and I'm not sure what's causing these errors. I don't know if you can see that now. I'm displaying sort of this error count here. You know, those are failed transactions on the I²C bus where I can't get the data out of the Romy I²C slave. And I've looked at it a little bit on the I²C bus. It didn't look to me like it was a clock stretching issue. It was more like the Admega didn't respond or not in time or something. Again, I haven't gotten to the bottom of that, but it's not really getting in the way of things. I have actually done some experiments because I've read these sort of mixed messages about clock stretching being fixed and not fully fixed, or sort of improved on the on the Pi 4. And so I've done an experiment actually just a couple days ago. In fact, I've used the QT Pi on the bottom here for that experiment, where I've deliberately slowed down the I²C slave in software by basically adding delays to the interrupt handler. And you know, if you look at things on the logic analyzer, you can clearly see that kind of depends on what kind of transaction is going on, but you can see, like, you know, an ACK bit coming back from the slave like X number of microseconds later, whatever I choose, right? If I choose to insert 100 microsecond delay, I can see, you know, the address going across and then my slave acking it 100 microseconds later. Or the other transactions, right? Again, the delay, you know, becomes apparent in different places in different ways. But my point is, the Pi seem to be perfectly fine with that, right? Again, it's supposedly clock stretching doesn't work on the Raspberry Pi 4. But again, I added like 20 microseconds artificial delay, 100 microseconds delay, and I could clearly see that the effect of that delay, you know, on the logic analyzer, you know, everything getting slowed down. And specifically, you could see the evidence of the clock stretching in action, yet the Pi was perfectly fine with it. So I'm not quite sure what's the deal. I think there's probably some corner cases that I can't quite, you know, artificially produce where it's not working. Again, I don't know where the definitive source is for that information, or maybe if it's the clock stretching, it's just a little bit, then it doesn't work. But if it's sufficient, then it starts working again, right? It's some corner cases that don't work with the Pi, but I was just pleasantly surprised that if I have a slow slave like an Admega that gets delayed somehow by other things it's doing, you know, I could clearly see, you know, the Raspberry Pi working perfectly fine. He was very happy with that clock stretching. So it's not quite sure what's the deal there, if it's really working or if it's not working with clock stretching.
So one observation, back talking about the SR04s, I noticed that you had held that foam up real close to it, and they have a minimum sensor distance that may have affected your results. They give bad results if you get within 2 centimeters of them.
Yeah, I haven't found it, to be honest. I found that I can get pretty close, and they don't give me, you know, they might not give me a reading that's smaller than 2 centimeters, but I'm not getting totally bogus readings.
Yeah.
You know, that's the case with the IR sensors for sure. If you go below the minimum or a little bit, you know, the IR sensors will suddenly give you bogus readings. But the sonars, I can't say that I have seen that. Let me try that right now. No, I can't say that. I mean, there's a point. What I've seen, if anything, and similar to the IR, as you get below sort of the minimum distance, which seems to be 15 millimeters here for me, the reading starts to increase, right? So I'm reading now 45 millimeters, where in reality I'm like 5 millimeters away, but I'm not getting like totally bogus readings like, you know, 1 meter away. If so.
Yeah, I haven't actually tested it. I've just read that. I know on my little bit of use with it that in my object avoidance, it doesn't avoid the object. If it gets too close, it doesn't see it. It thinks it's way out there. So
yeah, that's definitely a big concern always with the IR sensors, because they have a very strict minimum distance, and if you go below that, you know, it start to give you readings that make it look like it's much further away.
Yeah.
Right. In a way where it can be pretty tricky, and that's why I found mounting them at an angle like that is actually beneficial, because that way, you know, you're actually artificially adding a little bit of distance between the robot and the wall on the side, and so you're not as likely to go below that minimum distance. I've also seen people, you know, deliberately crisscrossing the sensors, where the sensor on the right is watching the wall on the left, right? And the other way around, a little bit counterintuitive, right? But again, just to overcome that problem of minimum distance, because by having this sensor look this way, you kind of artificially adding distance between the sensor and the obstacle it's going to see. But you're right, those issues you have to look out for. Again, I haven't run into that as much with the sonars as with the IR.
It was interesting that you talked about the different sensors themselves behaving differently. I hadn't thought about that. I'm gonna have to.
Yeah, and I don't remember who brought it up the other day. It probably was Doug, right? That they're just, I mean, they're dirt cheap. You get what you pay for. The manufacturing tolerances are like crap, right?
Yeah.
So every sensor behaves a little differently. I honestly didn't expect this much of a difference. And when I looked at them in the past, I have tested them in the past, but probably I haven't gone out, you know, in the distance as far, and I was more concerned about how fast I can ping them. I remember that much. I was looking for sensor, you know, I was trying to see, okay, how fast can I ping a sensor? Because some of them I was able to ping every 20 milliseconds. Others, you can't really ping any faster than once every 40 milliseconds, right? So there is that kind of difference as well. In addition to,
they have a delay on the reading time, and I forget what that is, but that slows them down.
Exactly. So there's some of them, you know, you can, for whatever reason, I don't know if it's a hardware difference or whatever, but for some of them, you can manage to ping much more often than others.
Question, do you have a fail-safe in terms of a bumper or something?
Not right now. I do have also a couple of very short range, you know, digital, quote unquote, digital infrared sensors that just tell you if something is within a certain, you know, within the range, and it doesn't have this problem of a minimum range. Again, things I bought many years ago. I was thinking of making use of that, but that still probably doesn't replace a bumper in a cluttered kind of environment with chair legs and whatnot. So the short answer is I don't have one. I don't have any specific plans right now, just because, you know, I want to put some logic in place and probably make that a priority, but I really should have one. I need one. Let's put it that way. I just probably don't have the time for it.
Yeah, the two ways that I've seen people do it is either a physical bumper switch type thing or measure the current of the motors.
Yeah, well, the other thing I mean, I do have the accelerometers on it, right? So I have what the B&O 85, and then I have accelerometer on the Romy controller itself. So I could tap into that also. I mean, again, I haven't tried it, but you know that should register. I mean, a signal for sure. You know, if I suddenly bump into something. But again, right now my problem is I need to get back into sort of writing some code, right, making it actually do something useful. In the end, that's the hard part. I mean, as fun as it is just tinkering it around, I mean, the reality is, you know, it just requires a lot more brain cycles to make it actually do something. And, you know, sometimes we don't have those brain cycles.
Dave, I have tried using the accelerometers to determine if I've run into things, and that turns out to not be trivial because there's bumps and stuff all along the way. And so what you're trying to do is separate out which bumps are actually when I ran into something and when I should recover. And just too many false positives.
Yeah.
That turns out to be kind of hard to do. I found another way you can use the IMU to compare what's happening to the body to what's happening to the wheels. I'm going to talk about that in my little talk in June. But basically, if you have wheel odometry and you also have a rate gyro, they should most of the time present you with the same numbers. And if they're very different, that typically means you've been shoved or the wheels are sliding, and you can use that like a virtual bumper.
Yeah,
right.
I would expect even just standing still, the way things tend to be noisy about, you know, maybe these IMUs may not tell you you're actually standing still. Maybe they may be chugging along a few millivolts here and there. And
yeah, there will be noise, but
right.
but there'll be, if you bump into something, you're gonna get a huge signal. But what David is saying is, as you travel, you know, normally, if the floor is not perfectly even, you're gonna get these spikes, huge spikes. I mean, we're not talking noise spikes here. We're talking, you know, spikes in acceleration. You're gonna see that. I understand, but what you know, I'm not, you know, the noise that you get even when standing still is literally in the noise compared to the other signals that you'll pick up. It's just picking out a bump from a, you know, a little crack in the hardwood floor. It might prove challenging.
Driving over a threshold or driving off of a carpet onto the hard floor or something.
It's amazing what people don't understand, because when I tell them I need my, you know, when I'm doing this 3D printing and I want it to be flat, and like, well, that's a flat piece of glass, it ought to be flat. And I'm like, nope, it's not flat. Here, let me show you. It's, you know, I have flat pieces of glass that are off by 0.2 of a millimeter from one side to the other, and have high spots and low spots between that on the same piece of flat glass. So put an eyeball on it, okay. Put a flat blade across it, in your eyeball, it looks mostly good. But then when you actually start measuring what you got, you'll be surprised how flat things aren't, right? If you never looked at it at that level.
So, you know, what would be interesting on that, just that problem, using accelerometers to detect hits. I haven't heard it on this channel, but in some of Harold's Hackster's channels, they talked about using something called tiny ML, tiny machine learning, and to do anomaly detection. So basically, like you could use these, and they're made for embedded devices, so that, and accelerometers, in fact. So like you have the accelerometer, and you capture some bit of normal looking data in the various conditions. So you basically build a neural net that's able to classify what normal looks like. And then whenever you have something that's out of the ordinary, for whatever combination of characteristics that it is, time, duration, power spectral density, whatever, the neural net's able to say, oh, that's unusual, that's an anomaly. So they've been using these kinds of things. I think like the SEC uses them to detect fraudulent trades real time on the stock market, but they actually, and those are the really fast ones, really fast detectors, but on high volumes of data. But I've seen, like there was I forget who it was, but one of the vendors that Harold Hackster found Hackster, they did a nice webinar on doing it, and they showed well, basically training the model an accelerometer to detect hand gestures, basically. So you'd hold it steady, and that's the nominal, and then this is a one kind of motion, and this is another kind of motion, and that's what's in your watches, by the way. I think when you're walking around and it's doing step detection, things like that, it's using the tiny ML models to look for anomalous behavior in crazy noise.
That might be real useful. If it works, my experience had been that what we were talking about, trying to determine if you've had a collision, that those signals don't look that anomalous. That's the problem.
So what I did, David, is I used the 3D accelerometer and computed the vector of the acceleration and compared it to the direction I was going. And basically, if it was, going opposite of whatever was forward, somewhere in the range of forward, then I'd assume it was a collision. And it worked fairly well. Occasionally, I'd hit like a speed bump type thing, and that would trigger it. But for the most part, it worked. Of course, I was driving fairly fast with that little robot, and when I hit something, I usually hit it really hard.
But yeah, something like that, that's a little more intelligent about what is considered an error condition and what's just the normal bouncing around of driving.
I think the old cat whiskers are the simplest and probably the most reliable. You just stick them out in front of it, and just a simple switch.
Feelers.
That's what I use to detect hands and running into the goalposts during the soccer contest, and they worked really well.
The only problem I had was the smallest ones that were still durable are these massive, giant switches. They're huge. If I could find a small one, it'd be great. But they took up so much space in the front of my robot that it was like 2 of them was just so much. But yeah, they work. They're not that expensive.
Oh yeah, really cheap.
But that's a lot of space in the front of a small robot.
Yeah.
All right, so who's next? I think Ted, we've been working towards you. Is it your turn yet?
Yeah, that works for me. Let me present here. So what I've been working on is more ways to get a little better ground clearance on my bot. And let's see. Yeah, here it is. And so I had this crazy idea of putting in some wheel camber in order to get the center of the robot higher. And I think, well, one of the problems is I got the center of gravity up too high, and I think I have a little too much camber here. But let's see, drive it around here. So it was a little unstable and had some issues. Let's see, is it going to, here we go. Maybe some point I'll start driving it. Anyways, it was, I don't know, it just wasn't driving very well. So I eventually reduced the camber a bit. Let's see, where is it driving? Here we go. Yeah, there's a lot of tipping and just bouncing around, but it sort of drove. So I'll kind of show you what I did next. And so this one worked a lot better, and it's just, I don't know, maybe 20 degrees of camber on the wheels, but yeah, that got it moving fairly well. So I think I'll keep something like that. I'm still thinking I want to put in some sort of suspension into it, but this was a fairly simple fix just to get it so it wasn't dragging along the ground as much.
That works great, Ted.
Yeah, except I can't drive.
When you had it up at a high angle, you're driving on the edges of the wheels. I mean, are the wheels pretty spongy? Did that have an impact?
Yeah, the wheels are really spongy. So let's
Yeah.
see if I go back to that guy.
'Cause I think the same ones. Are these the same?
Yeah, the same wheels.
Yeah, because they're really spongy.
Yeah. Yeah, mine are really spongy too. So I think that helped, you know. It was a little more traction that way because they flattened out, but still it wasn't nearly as much, you know, what do you call it, footprint on the ground.
Right.
Well, on your final version, what did you end up as your wheel-to-wheel spacing? I think we're calling that wheelbase now.
Right. That was it was around 9. I think it's around 9 inches, and the distance apart left to right is about 14 inches. So they're a lot closer together forward and back than they are left to right, and it seems to be turning well now.
Mm.
Yes. Are you going to make the chassis shorter?
Yeah, right now, that was just the, you know, kind of the length I had it to. That was easy to mount everything to. And I got, you know, the batteries and the speed controller, and I just needed some space to mount all that stuff. But I think if I, you know, once I get it finalized and the wiring cleaned up, then I can cut out some more of it and compact it down. Because that was another problem. I've got the chassis sticking out the front and the back. So, you know, when
that when it went off the steps there, it looked like it caught the front end of the chassis.
Yeah, it
Whereas
did.
if that had been cut off, it would just have caught on the front wheel.
Yeah, and I had some branches out in the yard I was running over, and they would sometimes catch on the front of the chassis. Whereas if I hit the wheel on a branch, then it just bounces over the branch. So, yeah, I need to do something to get the front of the chassis behind the front wheels at least.
Branches for outdoor robots are like those 5-legged office chairs for indoor robots.
Yeah.
The nemesis.
Yeah, so that's all I had to present right now.
Cool. Good progress. Looking great.
Yeah, thanks.
I think you're the only one on the show tonight who's actually got a moving something outside for a group focused on outdoor rovers. You're leading the charge.
Gold star.
Gold star.
Yeah.
We go for months with nobody even turning a robot on.
Yeah, I've been there.
Cool. All right. Well, thank you, Ted. That's awesome. So let's see. I think we've got everyone who raised hands at the start, but then other people came in board. So who else would like to jump in and share what's going on in their world?
have a picture. I made a picture.
Cool.
Ooh.
How do I do this? Present now. Your entire screen. Select window screen.
Isn't it funny how in the UI they said present now instead of present there? Or present this? They chose time.
Did anything happen?
It's coming up. We can see ourselves. There you go. Stereo sonar.
Okay, well, I just brought this up. This is a picture I'm working on for my talk, but I brought this up based on what Chris was saying. Chris, you can see I have a pair of those sonar. Now, these are the Polaroid sonar, so they see out a little further. But that's represented by these blue lines here. And basically those, to a first approximation, those sonar have a beam width of about 15 degrees. And so the two sonar, the stereo sonar, are offset about 10 degrees from the center line. And basically what that does is it allows the inner edge of the two to slightly overlap. So you have a left and a right and a sort of a center detection area there. And at least for these, you know, The response doesn't really look like that. It's got shoulders on it, and you know, it's a whole lot more complicated than that. But to first approximation, that's about correct. These also I guess I need a sideways picture. They're angled up at about 5 degrees so that the bottom edge of this is a cone, right? We're looking at a cone. The bottom edge of that basically stays parallel to the floor out until you get to about 16 feet, at which point it can see the floor. Having having sonar mounted on a robot that's just 6 inches tall is problematic because of the way the beam spreads out. The little red lines in close are the IR. There's 3 IR ranges, a left and a right and a center, and they can only see out to about 12 inches, but that's basically where the sonar doesn't do very well. So the IR takes its place. And let's see, I had another fun one where I added, oh, it's not here. Oh, well, that's all I got. How do I get out of this?
That's cool.
Hey,
Stop
David,
presenting.
just out of curiosity, of course, the Sharp makes the ones that go up to 1.5 meters, like the ones that I've been using, and I think Chris as well. Those are the 10 to 150 millimeter IR sensors. So you could replace the shorter 12-inch ones with a little bit longer IR range if you wanted. Is there a reason why you?
That would only. Let's go back to the picture. Let's go back to the picture. That would only give you a single point, unless you're talking about putting 20 of them. These are proximity centers that give me a big fat range. So anything that falls inside this left range will set off the proximity detector. In that sense, it's like a bumper. It's like a full coverage, a 3D bumper.
Right.
Does that make sense? Or does that answer your question? Replacing those with an IR sharp detector would give me one little line. It would not give me a whole broad area. I'm not saying this very well. Obviously, you need to work on it for the talk.
Well, but my understanding is, I think that the Sharp ones have like correct me if I'm wrong, somebody, but I think they have like about a 27-degree spread or something like that as well. And if you're talking about the analog ones, they don't just come back with a 1 or a 0. They give you a distance. So wouldn't that work?
No.
You're a lot of help.
Okay, let's see. Okay, you see this? Am I still presenting?
Yep.
You are.
Okay, these little lasers looking things, these are the Sharp IR detectors. That's about all they give you. These I use for wall following.
They're not wide.
No.
Yeah, they're definitely not 27 degrees, Murray. I mean, I haven't measured it exactly, but I think, maybe a little less than 10 degrees or maybe some 5-degree angle. I don't think it's a laser.
No.
All right.
It's actually, it's a little hologram that focuses the beam. It's actually kind of cool, but I would say 5 degrees at the max, maybe.
Okay.
Maybe
You were saying, I think last time, that they're a little X in a box or something like that.
Yeah.
Yeah. So these short range ones you're using, what are they then?
These are, let me grab it and I'll show you the picture.
Because they're clearly, I might be more interested in having some of those short range ones that David's using, because I was using my Sharps as proximity detectors.
See, okay. For one thing, it's probably not proper to think of them as short range or long range. These are totally different kinds of devices. I don't think you can see that at all. You see that piece of black tape there is to keep them from seeing the floor. Okay, you can kind of see it. You see there's a little cardboard box, and inside that is a detector. And on either side of that is an LED, an IR LED. So I have 2 of those. There's a left one and a right one. So that is that basically gives me those 3 ranges.
They don't give you distance though, right? It's just a Boolean.
No, it just, is there something there, yes or no? Out to about 12 inches.
So if you were to use one of the Sharp digital,
like this. Yeah. Oh, okay. You can see them here, kind of.
Yeah.
All right. You can see there's an LED on that side, and there's an LED on this side, and then there's a shadow box to keep the IR detector from seeing those LEDs. Right. The shadow box is connected directly to the plexiglass bumper, so that you don't get reflection back from the LED to the detector. And those detectors can see on the order of 60 degrees or something like that. I actually, the reason it's inside that shadow box is to reduce the amount that it can see. If it can see out too wide, you can't go through a doorway, for example. So I have them reduced so that it only sees out to about that far. Okay, obviously need to work on that part of the presentation.
So David, these are sort of custom-made sensors made out of an infrared LED and an infrared detector that you've put together yourself. They're not like a sharp detector.
No, they're parallax.
Oh.
It's a parallax gadget.
Okay.
And you have power and ground, and then you have two signals that can turn on either the left or the right LED. And then you have a signal back. And you know, one of the cool things about that is, since I have a left and right one, you can just turn off the LEDs and just read the sensor, and therefore you can use it to seek on a IR beacon, a 40 kilohertz IR beacon, if you just shut off the LED. So you can use them both as an avoidance device and as an approach device.
If I wanted to buy one of those things, I just search parallax infrared.
Oh, you're going to make me look it up, aren't you? Hang on.
No. I'm going to do it. I'm going to do it. I'm not going to make you look it up.
Well, let me go look at my code, because I probably somewhere in there described.
No, I found them. I found them already.
Yes, I have no reference to the part number or anything in the code. Where did you find it?
I just searched parallax infrared. But it looks like they sell a whole bunch of different things. Oh, here we go. Yeah, I just searched parallax infrared, and they sell the sharp sensors as well there. Oh, wow, they sell a lot of stuff. Okay.
Well, I don't see them here on that page right off the bat.
Well, they have what's called, no, that's not it. Anyway.
I'm sorry, I probably should have that more at my fingertips, but I don't.
No, that's all right.
That's all I have. I had some colorful pictures.
That's cool.
I especially like the ray gun for the.
Yeah, like they look deadly. Deadly wallflower.
Well, I was trying to show I had them divide up into 4 ranges, and that the last range, it just kind of fades out, but that ended up looking like a torch.
It's still nicely done. We appreciate it. That certainly beats red pen on white paper. So, okay. So who's next? Who else has something to show tonight?
Yeah, I can go.
All right. What you got?
Have been, let's see, probably about 1.5 years ago, I bought a linear actuator from Tanner's. There was no documentation on it, and I kind of assumed it was the one that I have in my hand now that I bought from Palulu, just got in yesterday. The one that I got from Tanner's was not strong enough to twist the wheels on the or steer the wheels around on the other mower platform, which it's a riding mower. There's only like 4 inches of travel of the thing, and even with the tires fully inflated, it couldn't turn it on just concrete, finished concrete, which is usually very slick. And so he didn't know, and I didn't know, and it was, I think $10 or something. So I just risked it and bought it and thought, okay, maybe I'll use this thing later on, but turns out I can't. So anyway, so I bought another one. The other one is $129. I know how much force it can produce. It's like 55 pounds of force. And that should be more than adequate to turn the wheels that, the distance that I need to turn them. So the other one had a potentiometer in it. This one has a potentiometer and limit switches, which is kind of the best of both worlds. You can't, force it to go beyond the two, fully out or fully in. It stops itself, and the only way to get it to go in the opposite direction if you do hit one of the limits is to reverse the polarity on the motor, which I'm just using another Polulu small motor driver with a huge cap on the top, which kind of dwarfs the board, but oh well, that's all I had. So, and I'm basically taking all the code that I've written and trying to basically port it over to an ESP32 board. So it has LoRa on it, and that's what I want to use to monitor the thing with. I've also got a relay board that it's got 4 relays on it. Right now, I'm just going to use one of them to basically kind of act as like an ignition switch. If I get into a panic situation and I think the thing's going where it's going to hurt something or somebody, I can just hit that and kill the motor and basically remove all the power from the mower, so it won't be able to drive itself forward. And it's pretty quick. I mean, if you kill the engine with a load on it, it goes down in a couple revolutions. So I think that'll be adequate for stopping the mower in an emergency situation. So that's what I've been working on.
Very cool. All right. Who else? Anybody else make some progress this week?
Hey, not much progress,
No?
but I was going to work on this using odometry to let it go straight line, but it's hard to restart my coding. Too much to think about. Maybe I started a new job. I want to show you guys the cool robots there. If it's it's pretty fun. I thought it's pretty amazing. Let me know if you guys can see my screen.
Ooh.
So yeah,
wow.
I joined a company making this type of surgical robots. It's
Cool.
like assistive what do you call this? Robotic assisted surgery.
That's unfair.
So-
You get to play with this stuff for a living.
That one on the right-hand side looks like my absolute worst nightmare. If I came out of like a coma and saw that thing coming at me, I'd be like, "Oh God."
No, that looks like the robot from Logan's Run, where they did all the plastic surgery and removal of stuff that goes crazy right there. Okay, I just dated myself.
I mean, look, it's maybe I'll tell you. So it's what I thought amazing is there's so many degrees of freedom in there. So it's like motor here, motor moving this forward, motor here to rotate, motor move it out, down, rotation, insertion. So, and what this does is basically someone sits here at the surgeon would sit at the console, and I can show you here. So yeah, so basically someone would operate a handler at his hand, and the system will translate the motion or all these rotation, every degree of freedom to the other side, and the other side is mapped into the robotic instrument inside.
John,
the
is
body.
this a Da Vinci machine?
It is, yeah. It's this
Oh, it
Da
is?
Vinci system. Yeah.
And you're working for them?
Right. I just second week now.
That's very cool. That my wife had surgery done with that. It's really amazing because the movement of the surgeon's hands is reduced, 1,000-fold for these little tiny movements. It's actually quite astounding.
Yeah, I mean,
Looks like it'd be
I
a
thought
woman's worst fear there for gynecology and obstetrics. So
Yeah, that kind of makes my toes curl up.
Yeah.
I have to say, when I look at the lab, it's a bit unnerving. So, but anyway, I mean, it's better than the big one, right? Smaller one is better than big one. So, but better no one at all. Anyway, I'm gonna get back to my robotic, but I just thought this is something pretty interesting.
Irrelevant. Nicely done.
Congratulations.
You have to give a talk
Nicely
on that.
done. Yeah, I don't get to work on this lower robotic part, more like the behavioral part on the higher level. So, but then anyway, I'll yeah, it seems to be a fun system to work on.
We'll expect a talk next year.
For sure. Yeah, a talk.
Ah, okay. I don't know.
Is this one of those robots? I've seen videos where they did some kind of machine, and the doctor was basically he'd slice a grape and then he'd suture the grape back together again.
Yeah, I mean, it's got all the instruments in there to depends on how good I guess it still depends on how good the surgeon is, right? So, but yeah, you can do all these stitching, tying the knots. I was seeing that. Yeah. Cool. Yeah, thanks,
one of the
guys.
First jobs I had at a high school was worked in an operating room, glorious title of ward helper. And what we used to do is collect all the instrument sets and resort them, count them, and sterilize them so they could be reused for other surgeries. So a lot of the things like, the orthopedics instrument sets look like carpentry tools. There were saws and, like things that look like a pair of, nippers or cutters or files, all kinds of, it was gruesome. So, and each OR had its particular, or specific set of instruments that were, something beyond a general set. So, but yeah, so I'm guessing a lot of those arms or whatever still have the same, little tools that look like carpenter's tools, drill bits. And
it's sort of like you don't want to see sausage being made.
Sausage being made? Oh, yeah.
Yeah, I've seen that horror movie too.
I mean, I guess if a surgeon, it depends on what the surgeon wants to do, right? So yeah, there are tools that does these like burning things away.
Yeah,
or
cautery
like
tools, cutting tools.
powering. Yeah. So I think it's something. It'll take me a while to get used to. So yeah, it was a bit unnerving when I watched the lab of like, okay, better not, best thing is not to get on the operation table and have someone to work on you.
Yeah, the cauterizing tools they give off the smell of burning flesh. It is, ugh. So I don't know if you saw any of those being used.
I mean, I think it's called a power tool, but yeah, there are basically it's like it can burn things away, like just pouring through.
Yeah. Uses current, electric current. Yeah.
Yeah.
Yep. Yeah. The let's see, what was it? It was a pelvic exam. So they have this thing. It's called an Alice clamp, and an Alice clamp has like 4 very pointy jaws on it, and there's actually like a little tab on the uterus, and they would use the Alice clamp to just basically bite into that tab, so they could pull the uterus in and out and manipulate it, and so the it's just like or the things, let's see, biopsy punches. They actually take a chunk of tissue out to be pulled out. And
they have grinders and deburring tools.
Yeah, that's what they used on my shoulder. They just milled out the underside of the one bone, which was
the shoulder
so
bone.
that so that it wouldn't dig into my supraspinatus tendon like it used to. But
yep,
basically punched a hole through the deltoid, got the grinder in there, sucked it all out.
Did it work?
So far, so good. Yeah, they had to. Then they drug the supraspinatus over and nailed it back down into the bone where it had torn,
and they did all that through just a couple of little holes.
1/4-inch diameter hole. One.
See, in the before time, they would have cut your shoulder open to do that.
Yeah, oh, I know. It's crazy.
Yeah, there's some gruesome things. That same operation, there was he was an Indian intern, and there was a thing called they called it a trocar, and it looks like a large stainless steel nail. It's got a point that has like 3 sides to it, and basically you just grab the stomach tissue and jab it in, and that's the holes that they were using for stick other instruments in for the arthroscopic surgery. Anyway, this guy wasn't very big, and he was kind of nervous. Got this hunk of flesh, and he's shoving it in, and you just want to go through the certain tissue levels. You just don't want to jam it in, because it'll hit other organs and things. And I think he may have hit other organs because he pushed a little too hard.
Whoops.
I feel like I got onto the wrong video conference.
Let's not talk about this anymore.
What's this BMI?
I get like all kind of queasy and hairs and goosebumps and when you hear your surgeon say, "Oops."
A childhood friend of mine whose name was Kenny Salisbury, and he was head for many years of the robotics lab at Stanford. And his whole thing was haptic feedback. So he helped develop those remote surgery tools. But what they were really looking for is they want the surgeon, when he's operating that remotely, to be able to feel, to have some what they call haptic feedback. He gave several examples. One of them was surgeons, if there's a cyst, if their hand is in there, they can squeeze the cyst and tell whether it's cancerous or not. It's kind of crunchy if it's cancerous. So, I mean, that's a skilled feel that you've learned after being a surgeon, for years. Right. So they'd like to have that information fed back through the robot arm as well, where he would actually be able to feel what he was doing. And they were putting a lot of work into that. What fascinated me the most was he said that the gold standard that you compare everything else against is just one of those old cable run, what were they called? Waldos? Have you ever seen one of those things? Cables, there's no delay, there's no digital buffering, it's all absolute, and you can feel what you're doing. You can feel the pressure on the other end. So he said that effectively was the gold standard that they measured against. That's a whole other branch of robotics that's pretty fascinating.
Mm-hmm. Haptic feedback, yeah.
Thank God, anesthesia.
Well, John, that was a good opening. So we're looking forward to more surgery-oriented robotics things. And as soon as you get the videos of the Matrix, right, where we're all in a capsule, and okay, okay. All right, so who can take us out with another topic, or are we going to keep going down the surgery lane on the operating table? Well,
I have a question.
What you got?
I would like to ask the group, has anybody used the DF robot ultrasonic sensors that are they're equivalent to the SR04? The question I had is, if you're trying to find a vendor for these type of sensors that would be consistent. Does know anybody had bought any of those, ever tried one? I mean, they're so cheap on other sources that tendency to pay a little more seems to be kind of counterproductive. But Parallax, I know, has one ping sensor, and it's okay, but it's pretty expensive. I was looking for something in between.
Is that one about $12? The one from Parallax?
Yeah.
No, 30.
No, it's $30, I think. Yeah.
That's more than 12.
Yeah.
I know it's what Chris was talking about. You can get a bag of them, for that kind of money.
Oh, yeah, I know. And the problem is every batch you get is different. I mean, really, every batch is different because they're being made by thousands of guys over there in little shops from parts that, the source control is crap. And sometimes you get a great one. Sometimes you get not so good. But I know that, we had that beginner robot series, and we had a lot of people buy those robots. And those robots each came with one ultrasonic, and it was a reasonably good ultrasonic, and it seemed to be consistent. So there's somebody somewhere is making, reasonable sensors. I'm just, and I know that they didn't pay any high price for their sensor because the whole kit cost $21.
Well, I have to say the ones I use that I'm so pleased with as I look back in it are, in point of fact, the $25 parallax ones.
Yeah. Okay. So then maybe you just have to bite the bullet and buy the good one.
It's
okay. I was just wondering if anybody had any experience with other brands. With branded SRO4s, as opposed to just eBay random SRO4s.
Was the original producer Panasonic? Is that who made them first or something?
No, actually, I think it was a company in England. A small guy in England was making them, and they're a little. The key secret to it was that they used an MAX 232, which is a RS. Yeah, it's a RS 234. But what it has is it has a charge pump in it, which allows you to get a really big pulse. Well, for 5 volts, you get a pulse, and that was his trick, and that's what started it all off.
You have to wonder though. I mean, if you can get a bag of them for $10, even if only two of them turn out to work real well, you're still ahead.
Yeah, that's true. The problem is you run into, all 10 of them are dead. All 10 of them are bad. Anyway, okay. I was just wondering if anybody had actually purchased any branded ones besides Ping. I mean, at one time, Ping was the only one you could get reasonably quick.
And the truth is, and maybe this is just me, if you were designing a product and you're planning to build tens of thousands or millions of them, then the difference between a $2 sensor and a $10 sensor would be significant.
Yeah.
But if you're just building one-off robots in your garage, the difference between a $2 sensor and a $10 sensor is insignificant compared to the amount of time you're going to put in.
Oh, I agree. Yeah, but
thing won't work.
Yeah. But the question is there a better solution? I was just wondering. Okay, that's really all I wanted to do. And
got me started, Doug.
I'm starting to, just progress-wise, I'm sort of where, I was looking at the Robo Columbus, and I already had a unit that's based on an RC scale, 10 scale, 1/10 scale, and it has an autopilot on it that can essentially, using a GPS, drive to within 5 or 10 feet of wherever the target is. So what I'm decided that the key thing that I'm going to try and spend my next bit of time on, and it's kind of cool because I don't even really have to worry about the GPS and all of that stuff yet, is simply in game. So I get, let's assume I'm within 20 or 10 yards of the cone, and I'm facing the absolutely worst condition. I'm facing away from it. What do I do to bring it so that it's looking at the cone and driving to the cone and controlling this cone? It's going to need distance sensors. It'd be great if it had odometry, but on RC cars, I really haven't been had much luck with odometry. and actually stop at the robot. So I'm going to try to, that's where I'm going to be working on. And so one of the key factors, Scott, and I'm not sure about you, Dave. Dave, are you using a Pixie Cam on yours? Do you know? I know Scott does. I can't hear you.
Yes.
Okay. So
actually, it's an old CMU cam too. But
okay, so it's a little different from the Pixie Cam, but it's the same type of thing. And also, because I did what they call Kickstarter, I've got one of those Husky lens, which if I can figure out how to retrain the back part of the model, I should be able to get it where it says cone, no cone. All right. And I'm thinking of using the Pixie and the Husky lens together to get like 2 viewpoints of the same thing, and see if that can overcome some of the lighting issues that can exist when you're trying to do it in bright sunlight or in shade or whatever.
One of the advantages of the CMU cam is you can control the color format. And
yes.
What I found was that if you put that in YRB rather than RGB, where R and B are the color and Y is the brightness, so that that solves a whole bunch of the problems of shadows laying across the cone and various light levels and so forth, because those basically you can expand the Y value that you're looking for and narrow in the color values.
I've found that too.
Another thing I did, Doug, I don't know if this helps you at all, but algorithmically, when I got to where the cone ought to be and the cone wasn't there, then I go into a spiral search.
Yeah.
And generally that finds it maybe in less than one complete revolution.
Right. Well, and I'm going to be a little different because I'm going to be using Ackerman type vehicle as opposed to a differential or skid. So that's going to, I don't know how, obviously you can't turn on a dime, and you don't want to go slamming into the cone if you don't know where it is, if you don't know where it is and you're turning and you're doing it at a fair speed, because it is hard to get those things to run slow. You might actually slam a cone. Anyway, what I was thinking about right now is try to get, if I can get like the Husky lens and both that and the Pixie going, the intent would be to try to catch the cone before you closed with it. Otherwise, maybe your waypoint is say 10 yards from the cone or 5 yards from the cone, but you're coming up in that 30 yards, you actually spot on your Pixie that what the cone is. Okay, and then hone in, switch over to in-game, maybe further out, and be driving towards the cone because you've already picked it up from a distance.
I think that's what we all do, Doug.
Well, no, most of it, if I've watched the tapes, it looked like you guys drove to a waypoint and then you started your search algorithm.
That's only if the waypoint turned out to be so far wrong that it wasn't near the cone. But at least on my code, and I'm pretty sure on Scott's also, the camera is scanning for the cone the whole trip.
Oh yeah.
And then as soon as it spots the cone, you switch over from navigation steering the robot to the camera steering the robot.
Okay, that's what I was thinking of doing.
Doug, you could get one of these and point your camera up into it, and you'll see 360 degrees around the robot. It's actually the reflector of a flashlight, a lantern.
Okay, cool.
Yeah.
Yeah, I have seen that. Yeah, I've seen that. I think the IR sensors on the Roomba are like that. They look like a little button.
I have to say, just if it helps anybody, that there's no possible way I'll be ready for this contest in August. I'm rebuilding that robot, and so I think Scott's going to enter.
Yeah.
Just based
I'm
on.
hoping you will be there. If nothing else,
I've got like
even
a handful.
even if you're not running, I'd like to see give
I have a
everybody
handful of things I
support.
have to do, which probably I don't have time between here and August. So anybody that thinks that between now and August they can build an entire robot, I'm in awe. I just.
I know what you mean. But anyway, we got to do what we can try. And like I say, we might not have anybody getting perfect 9s this time except Scott, but should be able to get at least a 3. So we'll see how it goes.
Hey, I'm going to be happy to leave the starting line, but can I have a question here? So on the cone, is there like a radius around the cone by which you can be pretty sure that you'll be able to see the cone, like at least the first cone I'm talking about? Or is there a chance that the first cone might be like hidden so that?
No, I think the first cone you can see from the origin.
From the origin, okay.
You should be able to, but it's not. If you read the rules, you don't have to. They could be over a hill.
But that's generally how we've done it, just to make it as easy as possible.
Yeah, the intent is the first cone is supposed to be for people who are just starting out. And that's me. That's me. I'm just saying is getting to the second cone is tougher.
Well, that gives a shot for those of us, because I mean, in that way, I can imagine that you wouldn't even need GPS. If you know where that hole is in the golf course, you just line it up and aim it and say, hold this heading and drive. And then
that's actually been done.
That should work.
Yeah, it's been done. There's where the end game comes in a little bit, though, because chances of you going 100 yards with a hand-aligned robot at where you actually hit the cone is pretty slim. So usually, what would happen is that you just drive on by, or you go 100, what you think is 100 yards, and stop. But we've literally had, in fact, a young gentleman who was, I think, in middle school, actually drove it and hit the cone, and he had a bumper on it, and it stopped his robot. And there's a few things you can do. You can turn your wheels. What the camber? I get no. The camber. What the camber is this way, isn't it? What's where it's the toe in? The toe. You can change the toe so that your robot will have a tendency to drive straight. You'll have a hard time turning, but it'll drive straight. So that's, I believe he did that. And he did a few other little tricks like that.
It's kind of the robotic equivalent of a Hail Mary, right?
Right, exactly. But it was pretty impressive.
But I figure if there's a gun sight on the robot or something you think of like a gun sight, and you get at the starting point wherever that is, and if you can see, or even if you have a person stand by, if it's below the hill,
nobody can stand in front of the robot.
No, I mean, you can walk the course though, right? Someone can walk the course, so you can see the cone. If you can see the cone, then you can use the gun sight from your starting point. You can know that heading, and then you can just lock that heading in, and then just have the loop keep you on that heading. And I figure that ought to get you pretty close.
Probably get you pretty close.
That reminds me of something you had said earlier, Carla. Y'all might want to double check that the speed controllers that RC car guys use typically often won't go into reverse, or won't go into reverse without a long dead zone in the middle. They're worried about the driver knocking that trigger back and forth and ripping the gear to pieces. So if you're going to pull up to a cone and stop and then back away from it, or if you're going to get into a dead-end cul-de-sac where you have to do a lot of maneuvering to get loose, that can be problematic. So be sure that the speed controller that you end up with does not do that. You don't want a pause in the middle, and you do want to be able to. The big hot rod ones that the guys race, none of them have reverse.
Right, they're all forward. I was looking at Castle, I think it's Castle Electronics or something like that, Castle speed controllers, and they had several different modes where you could do forward only or both, or speak of the devil. So do you like that?
Now this is one that's specific for a helicopter. So it drives a coreless motor, and it does things like you were talking about. It has a ramp up speed, so you don't, once again, grind off your gears when you first turn the thing on. It has a ramp up, but then after that, you need to be able to change the speed really quickly, and so it turns that function off. So it's a little microprocessor and everything. This one, every once in a while, things powered by lithium polymer batteries catch on fire. And if they're drawing 150 amps anyway, that can be a fairly intense event. And if it looks like it was the fault of the electronic speed controller, Castle will send you a new one for free, which is why I have this one.
Oh.
But what about the rest of the helicopter?
Well, what happened was, okay, this is 40 volts, right? It's a what is that?
Well, 10 cells.
Yeah.
10, 12, yeah.
Yeah, so it's 40 volts. And what happened when it burned up is that it applied the 40 volts to the 5-volt bus.
Oh.
So everything connected to the 5-volt bus had to be replaced. But this they gave me for free.
Score. That's a painful way to get something for quote free, but at least they helped you out with it.
Well, that's a real good company. Castle is I hold them up. I was actually very pleased with their response, and they sell a lot of stuff into the RC car and helicopter. Of course, on the helicopter, not only do you never drive it backwards, but pretty much you always drive it at a constant speed. You know, when you idle up, you adjust the response of the helicopter by the angle of the blades, not by the speed of the motor.
Yeah. Cool. All right. So let's see. Anyone else?
Hey Dave, what's your ground clearance on your 6-wheeled robot? I guess I'm assuming you put the largest wheels you have on it when you do the contest.
I actually I went to slightly smaller wheels. I have some. I don't know how to answer the ground clearance question. Are you asking like from the chassis to the ground, or you want to know from the suspension parts to the ground?
Chassis to ground.
Let me go measure it.
I'm guessing at least 6 inches, maybe.
That's 3 inches.
Oh, okay.
3 inches. But I had these big rock crawler tires on it, which gave it a little more ground clearance and a little better top speed, right? Slightly larger diameter. But I found over the long run that they didn't perform as well. The tires I put on them are called road rage tires, and they're actually quite flat. They don't have much tread on them at all.
Yeah.
And those seem to work a whole lot better.
Hmm.
Having the weight of the robot spread out across all 6 of those wheels and having them all stay in contact with the ground because of the suspension, there's not much wheel slippage. That's not the problem. But when you want to go when you want to turn, the front and rear wheels scrub sideways, and those big rock crawler wheels made that difficult. They wanted to grab a hold.
They were digging in, were they?
Yeah, because for that idea for a Mars rover, and David, you pointed out that most of them, well, not most, all the Mars rovers drive very slowly, but you could have kind of 2 modes: driving really fast when you don't see any obstacles, and then when you come upon an obstacle, slowing down and kind of going into Mars rover mode. But I was looking at, turns out that Servo City does sell actually suspension components that they can fit into their, into their system with little, I think they're air or liquid assisted shocks. So you could theoretically, if you wanted to spend the extra money, put shock absorbers on the Mars rover, but you just think how much more complicated that would get. But the idea of having
the whole concept of sprung versus unsprung weight kind of goes away in that kind of environment.
Yeah. Because I've ended up taking one of the standard aluminum chassis boxes and cutting it into a shape. That's my best estimate of it doesn't have a lot of spring. It's fairly strong. It's probably enough for, 6 of these on a robot would be plenty. And then I'd mount the motor on here, and this would go to the steering mechanism.
Mary, looks like a good start there, Mary. It really does.
Well, like I said, it's the only thing I could find that I literally went to the hardware store and just started going up and down the aisles trying to find anything that looked possible. And then I came home and I was staring at my bookshelf and I realized I had these aluminum boxes and I thought, well, they're strong. Unfortunately, they're $30 for one of these things.
Yeah.
And in New Zealand, this is a $30 box. So I'd need 6 of these. I have one.
My 75 cents plus whatever electricity it was on mine makes me feel, I don't know, a little better. Makes me feel sad for you though. But, yeah.
You don't have any control over the size. I mean, this is the size it's going to be.
Yeah.
But yeah, this is the only thing I've been able to find that's strong enough that would actually mount onto this thing. Because right now I'm just using the ones that Servo City has, and those are not long enough. So yeah, there's a lot to be said for their stuff. I mean, they've got some pretty brilliant hardware. I really like their.
And the way they've got the whole patterns all designed out, and they're the same between every part. Stuff just fits, right? And that's really cool.
The only downside, which I know you guys in the States, and I used to live in the States, of course, is that it's all in imperial units. I just wish they had gone metric. Because I go to a local shop. There's this big warehouse shop that's within about 20 minutes of my house called Coastal Fasteners, and they sell stainless steel nuts and bolts and stuff, and they have everything. But tell me how many, is it 320? No, what's the 826 or whatever? The standard
they're like 440s or 832s or
832, yeah. The 830, I think it's 832 this is all held together with. How many 832s in the entire warehouse? There was one small tray. It's just they don't do imperial here, at all, really. It's all metric. And
Mary, your design process, I know you've heard us bemoan the close of Tanner's. But that's what Tanner's was for. You go down there when you have a problem to solve and you don't know how to solve it. You wander up and down the aisles until you go, look at this thing. I have no idea what it is, but I could cut this part off and put a hole in it here. Yeah.
Okay. I did not have any double pull or single pull, double throw switches in my box, and I needed like one of each of these. So this is the power to the whole system, and this is the power directly for the. It's for the electronics. This is for the motors. And guess what I have a crap load of, because you got to buy these things in like 10 and 12s of, and I needed like one. And I'm like, damn it, Tanner's. I could just roll down there a couple of things later and had exactly what I needed.
And that switch would have been 25 cents.
Exactly.
Well, back in 1979, when I made my high school robot project for the first time, there was a surplus place in Des Moines, Iowa that I used to go to, and the actual structure of that robot was made out of 2 sandwiched PC boards that came out of a missile. They were big, giant, I think they're, 24-inch, 25-inch circular PC boards out of a missile that were just in surplus. And I just put 2 of those together with some screws, and I had this nice circular chassis. And it was just digging through there, like you said, going through the surplus racks and just seeing all this beautiful old avionics hardware and everything.
And I don't know that it's not just Tanner's. I don't know that there are any of those places left.
I can't find one. I mean, Fry's shut down. As much as I didn't like them, at least they had some of these things where you could get some. Micro Center has a DIY section over there, and they're going to have a smattering of some things, but it's if it's not a Arduino and you can just plug it in, they're not going to have it.
Well, if you think about it this way, is that like I remember in upstate New York, in what's the place that makes pencils? Small town. It's on the Ticonderoga. In Ticonderoga, New York, it's a little village and a paper mill, and they do a lot of wood stuff. And Ticonderoga, New York, was one in many small towns that fought to keep Walmart out. Because, of course, what Walmart did was they came in, surveyed all the businesses in the town, and then they built a custom-made Walmart, which is the way they all are, target the local businesses. So the same thing happened in Sacramento, where I was living, where they had this 160-year-old hardware store. And they had like a wagon wheel for sale. I mean, they had everything going back in their entire history. And that place got targeted. And so all of a sudden, and then moved in, started selling a lot of the same things, and even hired their employees when they went out of business. So yeah, all those shops are gone. They got taken over by ultra mega corporations that decided to push them out of business, because there's no way the little shop like that can survive when the average consumer would want to buy a $60 high quality hammer or a $10 made in Chinese one, made in China one. People just don't know that tools are worth it anymore. So those shops just disappear, I think.
Well, that was right down the street from me is Elliott's, and they have all the different screws, metrics, standards, whatever.
Yeah, where you up there in Plano? Is that what you're talking about? There's a guy, I don't know his name, but he's around there. He's the screw guy, and I'll tell you, that guy has been so incredibly helpful. It ain't even funny. I mean, I'll go in there. I need one of these things. Oh yeah. They're right over here on the third drawer down in the fifth slot over. He just knows his product. So
I know we went down to Elliott's and we found a 540 brass left-handed screw, which we needed
in stock.
Yeah.
The thing about
I had a whole drawer full.
How many you want?
Yeah. The thing about Elliott's is if you need 1,000 of these things, they're probably not going to have it. But if you need 2 of them, the chances are they're going to have that.
But that was very much my design process for years. And then just over 1 year, the Tanner's is gone. Mike's Hobby, where I got lots and lots of robots parts, is gone. Aero Hobby, where I bought all my helicopters, is gone. Plus they said, and also there's coronavirus, go home. It was just hard all the way around.
Yeah. There's
a bunch of places out there, though. I mean, I listed a bunch there in the chat: MPJA, Electronics Gold Mine, Alltronics, All Electronics.
But the keys are not local.
No, not local. No.
That's the problem. Because there was one place in Farmer Branch
like that,
and they were bought out basically by Ace. So guess what? They have now standardized Ace parts.
Yeah.
So that's the way with Walmart, though. The Walmart, at least now, the Walmarts, when I go to Walmart, they're not unique. They're the same copy everywhere you go.
Yep.
And they tend to have, cheaper products now and not necessarily quality products.
How about Altex? That place used to be up in Addison. Is it?
There's one up in, Addison.
But they got a smattering of small electronics of something, relays, but they've gone mostly PCs, USB parts, monitors, and they're selling to the industrial version of electricians and all that sort of stuff. They're not.
In other words, they're isolated their parts to, basically a Walmart type
AV, and
go for the mass,
audio visual stuff, all that kind of stuff that you would do if you had electronics going into a home, as opposed to what we would be doing. Yeah.
If you were doing like racks for small data centers, wiring closets, or home stereo.
Yeah.
But not if you needed to buy a 2N22 NPN transistor.
No, you're not buying those there.
No, but if you wanted to do a home security system, do they have the selection of cameras and gear you could cobble together? And for some reason, they would sell processor boards and all kinds of assorted weird things, but not really well suited for hobbies, I think, in most cases.
Yeah.
At least for the kinds of things described.
Well, I realize this will only give me a little tiny violin, but you guys can imagine having lived in California and then moving to New Zealand, the difference in availability here.
Oh,
Everything
sure.
is
Yeah.
You just have to talk about how wonderful it is in New Zealand and how it's worth it.
Yeah, I know. It's kind of a funny thing because in chat and emails and stuff like that, the subject comes up. Like when I was on Discord chatting with two what I think were relatively young people, and I said I got to go to bed, and they said, "What do you mean? It's like 6 o'clock." I said, "I'm in New Zealand." They all just went, "Oh, I want to live in New Zealand." It's like,
Well, I don't know, Murray, if you have. He's sent me a picture of just a short hike up behind his house, looking out over the grand ocean, and it's just spectacular.
yeah, it's about a 7-minute. If I walk 7 or 8 minutes, in fact, my partner, she walks up there and goes in and hangs out in the woods. We've got a reserve, they call it, park, and it's just some woods. It's 7 minutes from the house. You walk up there, and if you go out of the woods, you go up onto a cliff, and you're about 150 feet above sea level, looking at north at an island. And it's pretty, yeah. There's no way I can not appreciate that.
Yeah, it's hard to take it back.
On that happy note, gentlemen, I think I'm out of here.
Okay,
right.
David. Hey,
That's
Harold.
all, guys. Have a good night. We'll see you Saturday.
Hey, Harold.
Well, that's this Saturday.
This Saturday. 3
This
days,
Saturday,
4 days
all
from now.
Yeah.
4 days.
Cool.
I have a question about the PLA you got the other day.
Oh, ask away. Yes.
Okay. You said you got PLA plus, but when I went down there, the guy directed me towards something called Tough PLA.
Yeah, I got Tough PLA. I do have PLA plus from a while ago, but what I just was using the other day was Tough PLA.
Okay, just wanted to make sure because
I was